Today we're going to cover the concept of reverse engineering alien tech, as laid out in the phrase "the stolen Arks." Reverse engineering alien tech. This is a huge, rich subject, part conspiracy history, part engineering thought experiment, part ethics and part geopolitics, historical and cultural touchpoints, scientific and logistical challenges, legal, ethical risks, governance ideas, and safe ways to research or tell the story. Fiction, policy, investigation. I will not provide any technical instructions, designs, or procedural steps that could enable construction, replication, or weaponization of advanced technologies. 1. What people mean by the stolen Arks. Reverse engineering alien tech claim. Recovered alien craft Arks, or devices taken into secret programs and dissected by governments, corporations, or shadow groups. Narrative. The technology from those recoveries was reverse engineered and used to bootstrap hidden capabilities, propulsion, materials, energy, surveillance. Variants. Ancient artifacts, Arks unearthed and hidden, crashed UFOs, modern wreckage, or confiscated alien artifacts and black sites. 2. Historical and cultural touchpoints. Why this idea persists. Roswell-era lore and Cold War. Secrecy. Crash craft plus government silence equals fertile ground. MJ-12. Majestic myths. Reports of black programs and whistleblower testimonies. Whether true or conflated, they shape public expectation. Ancient artifact narratives. Archaeotech claim older civilizations possess tech later hidden. Pop culture. Films, novels, TV constantly recirculates the theme, reinforcing it as a cultural archetype. 3. What reverse engineering means in the non-operational sense. High level. Examine an artifact to identify materials, architecture, modular logic, interfaces, and underlying principles. Then translate those into reproducible engineering concepts. Real reverse engineering. Legal, industrial, involves materials analysis, failure mode testing, decoding control logic, recreating specifications, and building prototypes, all done within safety, legal, and ethical frameworks. Important boundary. Reverse engineering a known physics objects is fundamentally different from copying a familiar device. You may be confronting unknown principles and risks, not just engineering challenges. 4. Plausible scientific and logistical challenges. Conceptual, not procedural, and known physics. Devices may rely on principles absent from current theory. You'll hit a conceptual wall, not an engineering one. Exotic materials, conditions, alloys, or field states that ain't be analyzed by standard labs. Without special equipment, contamination and biohazard risk. Biological or informational contamination is a real concern. Metaphorically and practically. Integration gap. Even if components are analyzable, integrating them with terrestrial systems can be impossible without the original supporting infrastructure. Instrumentation limits. Current measurement apparatus may be inadequate to capture how the device operates. Interpretation bias. Human analysts can misread purpose due to cultural, functional assumptions, assigning arcane intent where a mundane explanation fits. 5. Political, legal, and ethical risks. Unaccountable power. Secret programs concentrating tech and knowledge produce strategic imbalances and long-term secrecy harms. Weaponization risk. High probability of military exploitation and arms races. If any capability is weaponizable, human rights, testing, human exposure, or coercive use raises gross ethical violations. Historical precedents. Unethical human experiments. Environmental risks. Novel energy or propulsion systems could have planetary consequences. Evidence suppression and distrust. Secrecy erodes public trust and fuels harmful conspiracy spirals. A feedback problem. 6. Governance and responsible approaches. Policy concepts. International Transparency Treaty. A multi-layered agreement, like a nuclear or biological treaty to oversee recovered non-terrestrial artifacts with independent inspection. Joint scientific custodianship, multinational labs with public accountability, not single-nation black sites, ethics boards and forensic archiving, forensic teams, legal oversight and long-term archives of all analyses redacted only for safety, not forever, whistleblower protections and declassification pathways, secure channels for vetted disclosures that balance security with the public right to know. 7. How investigators and researchers can responsibly study the idea in non-technical, legal and ethical steps. Archival research, study declassified documents, program histories and credible whistleblower testimony critically, comparative mythology and material culture, examine ancient texts, megalithic architecture and ritual objects as possible cultural encodings, but avoid conflating myth with proof. Interdisciplinary teams, physicists, material scientists, historians, anthropologists, ethicists, and legal scholars work together. One discipline alone risks bad interpretation. Public science outreach, publish verifiable measurements, radiation, isotopes, provenance, and peer-reviewed formats when possible. Forensic standards, maintain chain of custody, lab protocols and independent validation before extraordinary claims. 8. Cultural and human impacts to expect if the narrative were true. Technological leap versus social readiness tension. Rapid tech advances could outpace governance, producing social disruption. Asterisk, mythic reframing. Religions and worldviews would reassess human uniqueness, potentially causing both turmoil and renewal. Inequality magnification. Whoever controls them. Tech could reshape economies, surveillance, and power structures. Narrative healing work. Communities may need cultural rituals to process loss, discovery, and the moral questions raised. If you found this helpful, please like and subscribe to see more. Thanks for watching. See you in the next video.